Objects can become electrically charged by having one material rub against another. This is called charging by friction. There are natural examples of charging by friction. Lightning is caused by clouds becoming electrically charged by friction with the atmosphere. Erupting volcanoes have even more friction, and volcano lightning can occur in the ash clouds. So where does electric charge come from? You'll be very familiar with this picture of the atom. The nucleus is made up of protons that are positive and neutrons that have no charge. Orbiting the nucleus are a number of negative electrons. We use the sign Q to represent charge, and the charge on an electron is one of the fundamental constants, so we give it its own symbol, little e, and its value is minus 1.602 by 10 to the minus 19 coulombs. So coulombs is our unit of charge, and we use a capital C to represent it. The charge on a proton is the same magnitude but with a positive sign. In nature, atoms are found with equal numbers of protons and neutrons, so they are electrically neutral. However, if we rub two materials together, charge can move, and so the numbers become unbalanced. Remembering the picture of the atom, you can see that the electrons are on the outside, and so they're the ones most easily rubbed off. So if an object has become charged, it's because electrons have been added or taken away. So just as heat will transfer between materials, flowing from hot to cold, electrons will transfer from one material to another, going from negative to positive. When ebonite is rubbed on fur, the ebonite picks up extra electrons, so it becomes negatively charged. The fur now has a deficiency of electrons, so it is left positively charged. There are two things to notice here. Firstly, charge is quantized, which means it comes in lumps or quanta rather than being continuous. It's individual electrons that are moving. This means the charge on an object must always be a multiple of the charge on an electron. And secondly, charge is conserved. If something is becoming more positive, something else must be becoming more negative, so that the total charge must stay the same. We can compare it to money if we had a cash-only society. Money is quantized, meaning it also comes in lumps. The quantum, or smallest unit, used to be 1 cent, but now it's 5 cents. And money is also conserved. If somebody is gaining money, then somebody else must be losing it. So the total charge on an object can be thought of as similar to the mass of a pile of bricks. Bricks are quantized also. They come in multiples of a single brick. And so if we assume they all have the same mass, the total mass of a pile of bricks will be the mass of a single brick multiplied by the number of bricks in the pile. So the total charge on the negative sphere would be the charge on a single electron multiplied by the number of electrons. Actually, if these have been rubbed on, they are excess electrons, because the protons inside all of those metal atoms will still be there too.